Good morning, good afternoon, and good night, everyone. Welcome to my channel. My name is Dealories Masyhuri. You can call me Dea because sometimes my friends call me Dea too. I am a college student at Universitas Sebelas Maret, and today we will discuss about three acid and base theories. I hope you like it and enjoy. The Swedish chemist Van der Arrhenius proposed two specific classification of compounds, termed acids and bases. When dissolved in the aqueous solution, certain ions were released into the solution. As defined by Arrhenius, acid and base reaction are characterized by acids which dissociate in aqueous solution to form hydrogen ions or H+, and bases which form hydroxide ions or OH-. It is now known that the hydrogen ion cannot exist alone in a water solution. Rather, it exists in a combined state with a water molecule as the hydronium ion, or H3O+. In practice, the hydronium ion is still customarily referred to as the hydrogen ion. An example of an Arrhenius acid reaction is hydrochloric acid. But if you see on your screen, first reaction from hydrochloric acid is really quite a weird way to present the actual situation, because the hydrogen chloride molecule does not interact with a single water molecule, but rather interacts with water as a solvent. When hydrogen chloride gas is dissolved in water, it dissociates into H plus and Cl minus almost completely. For all intents and purposes, there are no hydrogen chloride molecules in the solution. An aqueous solution of hydrogen chloride is known as hydrochloric acid, which distinguishes it from the gas, hydrogen chloride. Arrhenius acids divide three types of acids. First, acids that contain one ionizable hydrogen such as nitric acid are called monoprotic acids. Second, acids that contain two ionizable hydrogens, such as sulfuric acid, are called diprotic acids. Third, acids that contain three ionizable hydrogens, such as phosphoric acid, are called triprotic acids. Arrhenius base is a substance that when added to water increases the number of OH- ions in the water. The base dissociates in the water to form hydroxide ions or OH-. The most common examples of Arrhenius bases are the group 1, such as sodium hydroxide. Again, this is a reaction system that involves both sodium hydroxide and liquid water. The process of forming a solution of sodium hydroxide is just like the one involved in the interaction between sodium chloride and water. The ion sodium plus and OH- separate and insolvate, surrounded by the water molecules. The second theory is Bronsted-Lowry theory. Bronsted-Lowry theory of acid and bases took the Arrhenius definition one step further. As a substance no longer needed to be composed of hydrogen or H+, or hydroxide ions or OH- in order to be classified as an acid or base. In the Bronsted-Lowry definition of acid and bases, an acid is proton donor or H+, and a base is a proton acceptor. When a Bronsted-Lowry acid loses a proton, a conjugate base is formed. Similarly, when a Bronsted-Lowry base gains a proton, a conjugate acid is formed. A Bronsted-Lowry acid or base and its conjugate base or acid are known as a conjugate acid-base pair. Why ammonia is a base? It's because the Bronsted-Lowry definition defines bases as substances that accept protons or H+ ions in an aqueous solution. When ammonia is placed into an aqueous solution, the reaction, like on your screen, the first reaction and the second reaction, we can see that ammonia is accepting an H plus ion from water. The forward reaction doesn't occur in reality, so although ammonia is a base, it's a weak base. In the Bronsted-Lowry definition of acid and bases, a conjugate acid-base pair consists of two substances that differ only by the presence of a proton, or H+. A conjugate acid is formed when a proton is added to a base. A conjugate base is formed when a proton is removed from an acid. Example, ammonia is a base. It accepts a proton to give its conjugate. And NH4+. Similarly, NH4+ loses a proton to give conjugate base to ammonia. Therefore, NH4+ is a conjugate acid of ammonia. And example number 2 is hydrochloric acid. Starts with a proton that ends up on a water molecule, which acts as a Bronsted-Lowry base and forms hydronium ions. Hydrochloric acid is a strong acid. When it donates a proton, a Cl- ion is produced, and so Cl- is a conjugate base. The Bronsted-Lowry acid and base theory has been used throughout the history of acid and base chemistry. However, this theory is very restrictive and focuses primarily on acid and bases acting as proton donors and acceptors. Sometimes, conditions arise where the theory does not necessarily fit, such as in solids and gases. G. N. Lewis from UC Berkeley proposed an alternate theory to describe acids and bases. His theory gave a generalized explanation of acids and bases based on structure and bonding. Through the use of the Lewis definition of acids and bases, chemists are now able to predict a wider variety of acid and base reactions. Lewis' theory used electron instead of proton transfer and specifically stated that an acid is a species that accepts an electron pair while a base donates an electron pair. A Lewis acid is a substance that can accept a pair of electrons to form a covalent bond. And second, a Lewis base is a substance that can donate a pair of electrons to form a covalent bond. Various species can act as Lewis acids. All cations are Lewis acids since they are able to accept electrons. Example, copper 2+, ferro 2+, and second, an atom, ion or molecule with an incomplete octet of electrons can act as a Lewis acid. Third, molecules where the central atom can have more than 8 valence shell electrons can be electron acceptors and thus are classified as Lewis acids. And fourth, molecules that have multiple bonds between two atoms of different electronegativities. An atom, ion, or molecule with a lone pair of electrons can thus be a Lewis base. Each of the following anions can give up their electrons to an acid. Lewis bases highest occupied molecular orbital interacts with the Lewis acids lowest unoccupied molecular orbital to create bonded molecular orbitals. Conclusion of the three acid and base theories. The type of Arrhenius acid as H plus producer and base OH minus producer. Type of Bronsted-Lowry, acid as H plus donor and base as H plus acceptor. And Lewis, acid as electron pair acceptor and base electron pair donor. Don't forget to like and subscribe. Thank you for watching. Have a nice day, everyone.